Alright guys, welcome to Math 0314. We are on 6.7 solving radical equations. So, as a general rule of thumb, whenever you're solving equations, the goal is to get whatever the square root in this case, the function by itself. So the idea here is, let me subtract 5 and get the square root of p by itself. So the square root of p equals 4. Now, as we discussed previously, the square root technically means an index of 2. So this is the same thing as raising it to the 1/2, which is equal to 4. And because of this, we can square both sides, and we get p to become 16. Now, one of the most important aspects in all of this is you have to substitute the value back in and make sure that it's true. So clearly, if the p is 16, square root of 16 is 4, 4 plus 5 is 9, and this is a true statement. You'd have to always check, because sometimes it will not work. Let's look at the next one. So, think about what you would do to solve this, and then let's talk about it together. I'm going to assume that you've tried this on your own. And again, you want to get the cube root in this case by itself, so we'll add 2 to the other side, like in the previous example. We'll get the cube root of w minus 1 equals 4. Now, because the index is 3, this is actually the same thing as w minus 1 raised to the 1/3 power equal to 4. So now, to get rid of the 1/3, I'm going to raise both sides to the 3rd power. And this will give me w minus 1 equals 4 cubed. So hopefully now you're comfortable with the fact that 4 cubed is 64 and not 12. In other words, 4 cubed means 4 times 4 times 4, which is 64. And again, to finish it off, we'll add 1 to the other side, and w will equal 65. Again, you have to plug it back in, so 65 minus 1 would be 64. The cube root of 64 is 4, 4 minus 2 is 2. So, go ahead if you haven't done so already, pause the video and try this on your own. I'm going to assume that you've done that. And on this one, we're going to subtract 9. Again, the idea is to get the function by itself. So we're going to subtract 9 from both sides. And we get negative 2 equals, still thinking about w, x plus 3 to the 1/4. Just like in the previous example, we're going to raise this to the 4th to get rid of the exponent. So these will divide out. Negative 2 to the 4th is positive 16. Because a negative times a negative times a negative times a negative is 16, is positive, sorry, and 2 times 2 times 2 times 2 is 16. So this will give me 16 equals x plus 3. Finishing it off, we will subtract 3 from both sides, and x will be 13. Again, I want to emphasize, I know we keep getting it to work out, but we want to plug 13 back in here. 13 plus 3 is 16. The 4th root of 16 is 2, and we're left with 2 plus 9, which is not 7. So this actually does not have, this is no solution. There is no answer to this. So you have to be careful, and the reason why is this effect of the fact that when you take the 4th root of something, it can become plus or minus. So what would actually have worked, and that if this had become a negative, but we are talking about principal roots here, so that actually does not occur. So, be careful. Check your answers. Alright. Now we're going to get into the difficult scenario. So, in this problem, we're going to start it off like the previous one. We want to get the function by itself. So I'm going to subtract y. We're going to get 2 square root 4y minus 3 equals 3 minus y. Now you have two options here. Most people tell you to divide through by 2 to get the square root by itself. My advice is I don't do that unless dividing by 2 would cancel something out. In this case it doesn't, right? 2 doesn't go into 3 and obviously doesn't go into y. So I'm not going to divide. What I am going to do is to get rid of the square root, I'm going to square both sides. The catch here is that when you're squaring, this is a quantity on the right side. So even back on these problems, when we squared, the reason why you didn't just square 2, we took the 4th power of 2, we took the fourth power of negative 2, and the reason why we did that is that we're taking both sides of the equation, which do to one side you do to the other. Okay, so what this means, though, is that this 2 is affecting this 2 and also the square root. So this is going to leave me with 4. 2 squared is 4. When we take the square root of this, we're going to get 4y minus 3, and hopefully this is apparent because we said the square root is the same thing as raising it to the 1/2 power, and if we're multiplying by 2, these are going to cancel out and leave me just with 4y minus 3. On the other side, we're going to have to FOIL this. So when we FOIL this, we get 9 minus 6y plus y squared. Now, if that's not apparent, what I want you to see, which what I want you to think about, is that this is 3 minus y times 3 minus y. All right, so when we FOIL this, we know for sure this is going to happen. We're going to multiply these two together. We're going to get 9. At the end, we're going to, let me change the color here. At the end, we're going to multiply the y's together, and it's going to give me y squared. Negative y times negative y is positive y squared. And, let's go orange. In the middle, we're going to get negative 3y and another negative 3y, which means you have 2 of them, which is negative 6y. So this is why we say we just square this term, multiply these together times 2. So squaring this gives me the 9. Squaring this gives me the y squared. 3 times negative y is negative 3y. Doubling that gives me negative 6y. So that's the process that I undertook to get that fairly quickly. Next, I'm going to distribute here. We're going to get 16y minus 12 equals 9 minus 6y plus y squared. And the next question that should be emerging in your mind is, what do I need to do to solve this? So we've dealt with linear terms, which means we isolate one variable. But when you have three different types of terms, so we have a constant here, we have a linear term here, and we have a quadratic term here. So three different types, and here's a linear and here's a constant. So when we have a situation like this, what we want to do, and what you always want to do, is move everything over to one side. Doesn't matter what side you move things over to, but since y squared is positive here, I'm going to go ahead and subtract 16y from both sides and just add 12. So this is going to end up giving me y squared minus 22y plus 21. So note I put y squared in front because usually we have the leading coefficient in front. Negative 6 minus 16 is going to the same thing as adding 6 and 16 and making it negative. That's 22. And then 9 plus 12 is 21. This is equal to 0. And the reason why we want it equal to 0 is that we can use the zero product rule, which essentially says that we can reverse FOIL. So notice here I'm saying what times what is y squared is y and y. We're going to go to the back now, and we're going to say what times what is 21. Now, this is tricky. You're going to use 21 and 1, and I think the vast majority of people, when they first see that, are going to think 3 and 7. The reason why I immediately excluded that option was 21 and 1 add up to 22. There's no way 7 and 3 is going to even get close to it. So, but if you did try 7 and 3, that's fine. Remember back when we talked about this, I said don't think too much about it. I just think it's blatantly apparent that we want to use 21 and 1 versus 3 and 7 here. So in any case, these are going to become negative, so this is going to end up giving me, I could say y minus 21 equals 0, and y minus 1 equals 0. So when we solve this, we're going to end up getting y equals 21, and y equals 1. These are our potential answers. Hopefully you didn't just stop. You're going to take 21 and 1, you're going to go back to the original one problem, 21 and 1, and we're going to check to see if they work. So if I put 21 in here, we get 21 times 4, which is 81. 81, is that right? I'm sorry, 84. 84 minus 3 is 81. The square root of 81 is 9. So if I do 9 plus 21, I'm sorry, I get 9 times 2 here, because we still have the 2. So that's going to give me 18. If 21 plus 18 is 3, I would be correct, but they're not. So 21 is incorrect. And you can see what's going on here. We're using the positive version. 21 gives me the negative version, so that's why that's not working. Let me erase all this math here so we know 21 is not going to work. And now let's try 1. So if we plug in 1 here, we get 4 minus 3, which is 1. 1 times 2 is 2. 2 plus 1 is 3. This time it is actually correct. 1 is the only correct answer. So we're seeing again, you have to check. You don't want to do all this work and then miss the question because you didn't check. All right, number 5 is trying to intimidate you with the index of 3, but all I have to do here is raise each of these to the third power. So this is going to give me 2x minus 4 equals 1 minus 8x. And hopefully you see why, but if you don't, the reason why is that both of these are the 1/3 power. So when something is raised to the 1/3 power, that means that if we raise them to the third, these would divide out. So as any case, leaves me with 2x minus 4 equals 1 minus 8x. Next up, we want to solve it. Now here, as opposed to the last one, we only have linear terms. So here we just want to isolate x. So I'm going to subtract 2x. I'm going to get negative 10x. This is 1 equals negative 4. I'm going to, I've already used that color, let me go with orange. I'm going to subtract 1. You get negative 5 equals negative 10x. Then let's divide through by negative 10. Hopefully at this point this mathematics is fairly simple to you. And x is 1/2. Once more, that is not enough to say that is the answer. We're going to have to check. So if you put half here, half of 2 is 1. 1 minus 5 is negative 3. So this is giving me the cube root. Let me make sure I did that right. That's 1/2. So if I do 1/2, I get 1 minus 4 is negative 3. So this is the cube root of negative 3. Over here, we're going to put 1/2. Half of 8 is 4. 4 minus 3 is negative 3. So we also have the cube root of negative 3. So they both match up. They're both the cube root of negative 3. Since that is correct, and this answer of 1/2 is correct. Notice also, I do not know what the cube root of negative 3 is. I know I can take the cube root of negative 3 because the index is odd. And whenever the index is odd, that means you can have a negative radicand or negative argument. But I don't know what it is. And I don't need to. I just need to know that they both are the same value. So, hopefully that makes sense. Moving right along, we see here we have the square root of 3m plus 1 minus the square root of m plus 4 equals 1. So, what you need to do is isolate one of your square roots. In this case, you know what, let me make them all purple. In this case, I'm going to isolate the square root of 3m plus 1. It doesn't matter which one you isolate. I'm choosing that to keep everything positive. And then we'll take the square. We'll square both sides. So just like in the other example, when we squared here, right, this side the square root will go away. But on this side, when we square, I'm going to use this strategy of saying, hey, we can square 3, and that'll give me 9. We can square y, that'll give me y squared. And if I multiply 3 and y, I'll get 3y, and then double it. So here we're going to do the same thing. We're going to square 1, which is 1. We're going to square m plus 4, which will give me m plus 4. The square root of m plus 4, which gives me m plus 4. Remember again, when you square root, it goes away. In the middle is going to be the product of these two times 2, which is just 2 square root m plus 4. If you don't like that and you prefer to FOIL, that's fine, but you can see that this method, once you get more comfortable with it, is a little bit easier. And it's faster, so you're less prone to make, you'll finish things more quickly, and you're also less prone to make silly mistakes. Alright, so from here, I want now to get my square root, my other square root is still in existence, and I'm going to try to get that one by itself. So to do that, I'm going to move everything back over. Notice that really what we've ended up doing is we've ended up back with almost this sort of situation, right? So it's just one little more step, which is that you have to square both sides twice. That's essentially the only new part to this. Before I start moving things over, let's go ahead and consolidate terms. So I'm going to get 3m plus 1 equals 5 plus m plus 2 square root m plus 4. And you'll notice that I also rearranged it so that I have my number, my variable, in front of the square root. If you like that, you can do that. If you don't have to. It's just sort of a preference thing. So now I'm going to subtract 5 and also m, so I can end up getting 2m minus 4 equals 2 square root m plus 4. Now in this situation, we have to make a decision. Do I want to move 2 to over here? Do I want to divide through by 2 on both sides? And here I would, and get m minus 2 equals square root m plus 4. Notice that on the previous problem that was similar, here I didn't. I know there's a lot of work here, but I distributed the square part and I just left it as 4 here. And the reason why I did that was dividing by 2 on the right side, over here on the right side, right, correct, is not going to make the problem any more aesthetically pleasing. In other words, you'd end up getting 3 over 2 here and y over 2, which would make it really difficult to work on the problem. So because this makes the problem cleaner, I went ahead and did that. So you have to do a little thinking. It's not just all let me just follow the same process every single time. Think about the situation if you can make it better. So now we're going to square both sides. And again, you can see that we have m minus 2 quantity squared. So we have the same effect as what went on over here. So this is going to become square m is m squared. We square negative 2, we get plus 4. These multiply together times negative 4m. Right, again, m times 2 is 2m, times 2 is 4. Because it's negative, it retains its negativity. The other side is just going to become m plus 4. And because we have 3 different terms, we have a trinomial, so the goal needs to be that we want to set one side equal to 0. Here we're going to get m squared minus 5m equals 0. Now here, because I have 2 different terms, and if I don't have a trinomial, I only have 2 terms, because the negative here, the 4's cancel out. What I'm going to do is, instead of trying to do some sort of foiling technique, I'm going to factor out an m, because they both have m. I'm going to be left with m times m minus 5, 0. So this either means m is 0 or m minus 5 is 0. If m minus 5 is 0, I hope it's clear that m is 5, right? 5 minus 5 is 0. So we have to still test these. So after all of this math, we're not done yet. We got to test. So we go back up here, and we're going to plug in 0. So this is the square root of 1 is 1. We're going to plug in 0. The square root of 4 is 2. 1 minus 2 is not 1. Again, that's they're assuming that if this was negative, it would work. It's not, so it won't. So we're not going to use 0 here. That would be incorrect. And we're going to test. I'm going to do this in purple. We'll test 5. So if we plug in 5 here, we're going to get 15 plus 1 is 16. Square root of 16 is 4. If we plug 5 here, we're going to get 5 plus 4 is 9. Square root of 9 is 3. Now 4 minus 3 is 1. So the only answer that works is m equals 5. So very important at the end, you always want to check your work. All right, one more. So this is very similar to what we just did. So if you haven't done so already, pause the video, try it on your own. I'm going to assume that you've done that. This is nice because it's already been set up. So the value of square root m 5x plus 4 is by itself. So we said we're going to square to get rid of the square root. We're going to get 5x plus 4. this point, if you've been watching the video, hopefully you can easily FOIL this. We get 1. The back is going to be 5x minus 3. The middle is going to be 2 square root 5x minus 3. Again, square 1, it's 1. Square, it's the square root of 5x minus 3. You're just going to end up getting 5x minus 3. Multiply 1 by the square root of 5x minus 3. That's the square root of 5x minus 3. And then double it, so 2 times that. And we're ready to rock and roll with this. So I'm going to go ahead and consolidate terms on the right side. And we get negative 2 plus 5x plus 2 square root 5x minus 3. The left side is still 5x plus 4. We're going to want to put the negative 2 and the 5x on the other side, so we'll add 2. And we're going to subtract 5x. So this is interesting. We're going to end up getting 6 equals to 2 square root 5x minus 3. So again, we have a decision to make. Do we divide by 2 or not? Clearly, dividing by 2 makes the problem easier. And now all I got to do is take the square root of both sides to get rid of that squared. So we'll do that. 9 will equal to 5x minus 3. We'll add 3 to the other side, which will give me 12. Divide by 5. X is 12 over 5. It's ugly, but we can work with it. So let's see if 12 over 5 works. Notice that this is a 5, so 12 over 5, let's see if I can write this in here. So 5 times 12 over 5 plus 4 is actually pretty easy to solve. These will subtract out. 12 plus 4 is 16. The square root of 16 is 4. So we'll have 4 on the left side. Over here, again, the 12 and 5 will cancel out, so I'm just going to write 12 here. 12 minus 3 is 9. The square root of 9 is 3. 3 plus 1 is 4. So they match up, and that is correct. So you're essentially, you can see that these problems are sort of repetitive after a point. The big thing is just watch your signs. You're gonna have to square multiple times, and you really do want to. I think the strategy and the rule that is very beneficial is this one here, right? You want to get comfortable with that because these problems become a lot easier if you are. You can always, of course, FOIL, but foiling takes a lot of time, and when you're doing 10 of these, you want to go by as quickly as possible. In any case, I've been talking for too long. Hopefully this all makes sense. Let me know how you feel about it, and I'll see you guys in the next video.